volumes with known cross sections, or cross-sectional volume. The cross sections are our shapes. Okay, these shapes that we've been looking at, right? So from yesterday, what is the area of this square?
B squared.
Okay. Semicircle.
I over 2 squared divided by 2.
And you understand where we got that, right? Because the radius is b over 2. All right, how about this rectangle?
B squared over 2.
Yeah. Or however you want to write it. Isosceles right triangle.
1/2 B times B.
Same thing, right? And then we did some math yesterday to figure that one out. Okay. When we do these formally in calculus to get an exact answer, if we just did an estimate, an overestimate with a right-handed Riemann sum, right? When we do these exactly with calculus, we have to use what function? Or what calculus are we going to use, probably? An integral, right? Okay, so there's only one little thing that you're adding to your integral knowledge here, and that is the area of this shape. Okay. So this function, here's how the problem might be stated. Region B is the area bounded by the x-axis, x equals 9, and the y equals the root x. That's what we did on our boards, right? Bases of cross sections are perpendicular to the x-axis. Perpendicular to the x-axis, that's the base of our shape, right? Just like that. Good with that? Okay, so that's a statement you'll have to reconcile in your mind. If it says x-axis, we're perpendicular to the x-axis. Okay, like we worked with on our boards there. Okay. What's the volume of the solid created by those cross sections? So you can see what it looks like, right? Here's the root x, and then the squares come up. If I wanted to just calculate the area under the curve, the area of B, how would I do that? No. Area of region B.
B squared.
Integral from 1 to 9.
0 to 9.
0 to 9 of f of x.
Correct? Okay, so that's just the area.
Oh, B is that whole area. It's not
B
just
is the
line.
region.
Oh, I thought B was the line.
No, this is the cross section.
Yeah.
Okay, now what's the volume of our new shape with squares on top of it?
That's the integral times B squared.
That's the same. The question is what goes here.
Root x times
Okay.
B squared.
It's the area of each square.
That take volume of squares.
Yeah. I'm going fast. I'll slow down here. That's a 9. Okay, so if I were to put this B, the base in terms of x's, how tall is that base?
2.
B2.
Quarter root of 2.
There you go. So in general, root x, right? Because that's the function.
Oh.
So this would be root of 1, root of 2, square root of 3, square root of 4, square root of 5, right? So root of x, the square root of x value. Okay, so what is the area of this square that is root x by root x?
X.
Yeah. If you want to write it like that, or just x, correct? So all you're putting here is the area of that shape in terms of x. Okay, so this officially becomes a very easy integral, right? It's putting this together is where most people get stuck. Okay. But are you on the same page that this is just the area of the square? Okay. So we can finish that up, right?
X squared over 2.
Antiderivative.
81 over
So we get 81 over 2 minus 0, right? There's your volume. If you're in particular, you're in cubic units, right? It's a volume.
What is that?
It's just a U, right?
U cubed. 81 over 2 cubic units. Okay. Any questions? I'm going to move to this one. It's a little bit more straightforward. Wow. Okay, so we have actual pictures of the shapes this time. Just like you guys created, this class created them. Okay, so let's do this triangle. Again, region B is the area bounded by the x-axis, x equals 9 and root x. Bases of the cross-sections are perpendicular to the x-axis. Right, we're perpendicular to the x-axis. So, what is the area of that triangle in terms of x? We have to write this in terms of x.
1/2 b squared.
Yeah, so it's 1/2 b squared if you're in B.
1/2 x squared.
You're very close. What is the
X squared
function?
over 2.
What
it's
function?
root x.
Root
Root
x,
x over 2 squared.
right? So 1/2 root of x squared. The base is the function, right? Because I'm putting my triangle.
Wouldn't that just be 1/2, right?
Yeah.
Okay.
Yeah, so here's your area that we're going to use in the integral. Okay. So what's my integral?
9. Back to back. So root of x.
Volume integral or regular integral?
Volume.
Okay.
See, all I've done is put the area in there.
Can you find an antiderivative?
Because this is b, correct? The function is the square root of x, so b is root x. We'll substitute root x in for b. And then root x squared as x.
Would it be 1/2 x squared over 2?
Evaluated from?
0 to 9.
Again, we've been having some notational issues there. Make sure you're writing it as expected.
So 81 over 4.
So it's half as large as the squares, which makes sense, right? It's a triangle. Isosceles right triangles, in fact. Anybody confused?
I just don't know where to put it.
1/2. The antiderivative is 1/2 x squared over 2. You see it now? 2 times 2.
So then it's just x squared over 4. Oh. You got it.
It's fine.
You got it.
Hey, I understand a lot more than.
All right, let's try the rectangles. Okay, what's the area here?
1/2 b squared.
Yep. Which we already figured that out. So in terms of x,
1/2 x.
1/2. Yeah, 1/2.
yeah, so if we write it in terms of x, we get,
The rectangles are the same as the triangle.
How does that work?
And then, wait, no.
Yeah.
it's just the way we set the height up. It is still half of a square. Because if it was b times b, it would be a square. We're in half of b. We're half a square. So oddly enough,
It's still the same integral.
we get the same. And that's just because we set it up that way. It's not a pattern you can notice. Okay?
That's weird.
All right. So,
So 1/2 x.
all right. Let's take a look at the semicircles.
Mr. Arthur, you got a question?
Oh, okay.
On the, when we got the integer, the 1/2 x squared over 2, if you just plugged it into that, would it be still the same answer?
Yeah. Oh, yeah. That's math. It works really well like that. Nice and consistent.
Okay.
Yeah.
Because I never think to, I would just read it like that if I was.
That's fine. Doesn't matter. All right, semicircles.
They're just half.
Yeah, so we already did the area for this in our warm-up, right?
Yeah.
It was
Pi times b over 2 squared over 2.
now we have to put that in terms of square root of x.
Pi over square root x over 2 squared over 2.
Pi root x over 2 squared over 2, because that's b, right? Square root of x is b.
Couldn't you make that 2?
No. What?
Can't you do fraction division and make that 2 times the root of x over 2 squared? And cancel out the 2's?
Let's simplify it then. Pi, what does this become?
Root of 2 of x squared?
X over
Over
4
4.
over 2, right?
Wait.
And what does that simplify to?
Pi over
I can't
pi
do
x
fractions.
over 2.
Pi x over 8.
Okay.
Because this becomes copy dot flip. It becomes 1/2 when you multiply it, so 2 times 4. Okay. Again, hardest part is generating this right here.
Yeah, that's right.
So you need semicircle area and your function, and you're good. So-
Integral of pi x over 8 from 0 to 9. dx.
Oh.
Yeah, you just put your area formula in there.
And then
That's all you're doing. Plug and chug.
So then the antiderivative I x squared over 18. Oh wait, well.
16,
Yeah.
because 2 times 8 is 16. Am I going too fast?
Why do you split away the pi there? What purpose was that?
It confuses some of your classmates.
It does. It confused me.
Doesn't matter how you write it.
Are you dividing by 2 because of the exponent?
X squared over 2, yeah. Add 1, divide by 2, right? So we get 81 pi
Over 16.
16. And the 0, again, it just gives us 0. And we're still in volume units.
Can't forget units.
Though you can. Doesn't mean it's okay. Just like you can speed down the freeway, but doesn't mean it's okay.
Yeah.
I do speak.
I have no doubt about that.
Oh, this is ask people how you drive down the line.
Yeah, people probably clearly go.
Dang it.
Haven't been pulled
That's
over
7
once.
points.
I'll just wait as they drive by.
Sometimes that helps. Smile and wave, boys. Just smile and wave. Okay, are you good with those 4? All right. Let's talk about one where the cross sections are perpendicular to the
Y-axis.
y-axis.
Oh, is this the one with?
This is left and right instead of up and down.
Yeah.
Yeah. So region A is the area bounded by y equals 9 and y equals x squared. Bases of the cross sections are perpendicular to the y-axis.
Wait. How is this the left and right?
Okay, there's your clue. Are we in terms of x or y?
Y.
Okay. We are still 0 to 9 because it's 0 to 9. dy.
How do you identify that?
Because it says the cross sections are perpendicular to the y-axis.
Y-axis,
Oh, okay.
perpendicular. So that means we're in terms of y now. Correct? Okay.
Can you have it perpendicular to like x equals 2 instead of the x-axis?
You can. We're not going to.
That's not something.
We're not going to get there, but it can be done.
Okay.
Yeah. There's just not enough time. It's another day, but we don't worry about it. Okay. So here's the question. How do you calculate the base of that square, or the area of that square in terms of y?
You plug in.
So is this in terms of y? No. I have to write it x equals what?
Y squared. Square root y.
Over here.
To get your positive or negative.
How come positive?
Yeah, why?
Well, if you only consider positives, you only get this side.
Oh, gosh,
I don't get the other side.
You don't get the negatives. Because square roots do not generate negatives, right?
Right.
So you have to put that out front to generate those negatives. Right, so this side is,
Positive.
and this side is.
Negative.
Yeah. So, how large is the base of that?
Whatever that unit is.
Y.
Zero.
0. No, not 0.
Remember,
It doesn't go over the x-axis. It's not 0.
right minus left. Right? If you're finding the area between two
Zero.
curves. You're choosing to be distracted. Right minus Left.
So it's gonna be added to the spot.
2 root y.
Oh, that's stupid.
Okay, so that is how large the base is.
2 times root y.
Remember, right minus left. Okay, so what is the area of this square?
So the area formula doesn't change, right?
2 root y
Squared.
squared. It's a square. Right?
So 4y.
Could you simplify that?
And that's where
That goes.
that goes. Again, out the back end, not too difficult, right? You just have to get to this point. So, who's stuck? It's okay to ask questions in here. I know I'm like intimidating, but
I understand
I'm
why
trying
you did all
to
that,
figure out
but
if I can.
I wouldn't,
Yeah.
I wouldn't know to do any of that myself.
right.
I understand exactly how you got it and
Yeah,
why you did it, but doing
Okay,
it for
so-
myself is a different story.
So the first thing we do is figure out size of B in terms of X. Right? So we look at where the square is sitting. How big is that in terms of X or Y?
Okay.
That's what we did here. In this case, we had two curves to consider
Right.
because they're split, right? Y and negative root y, so right minus left. Here, this is x-axis, so I'm going to do top minus
Bottom.
bottom, right? That's how big those squares are. Then you calculate, the second thing is the area of the shape in terms of x or y. Okay, so then you're gonna, what we did here, what's the area? Well, square area is base times base, base squared, right? And then the third thing we do is plug into. Does that help your thinking?
Yeah. Why do we keep using like the square root?
Because that's just the function we're given.
It doesn't give us y with x squared.
We're gonna, well, yeah, but this one was in terms of y, because it's perpendicular to the y-axis. So we had to put this in terms of y. Which is a root. Yeah. We can do this one, and it doesn't have a root in it. You want to? Okay, Montaigne.
Normally when we did the vertical integrals, we would evaluate two different functions, not a function by itself. I don't understand that. So like you're splitting that one y equals x squared in half, and then evaluating the integral subtracting itself.
Well, they're different though. This is a negation of it.
So if it ever passes the y, if it ever passes the y,
Yeah, so when you're working with the y-axis integral,
yeah.
you're probably going to have to split the two functions up.
What if it wasn't the origin at 0 though?
It's still right minus left.
It'd be different.
The area calculation would not be different. I can move this shape wherever I want. It's still going to give me the same area. It's no different in size.
But if it's translated to the right two units, then your right minus left is different when you subtract.
It gives you the same result. Because if it's translated 2 units, the function
Yeah.
is,
Root y minus 2?
no, yeah, sorry, root y plus 2.
Okay.
This is negative root y plus 2. So when you subtract right minus left,
Okay. Yeah,
2 minus 2 is nothing. Okay. Okay, let's do this last one, and we'll be done. And we'll see if you get it. Too far. Okay, so the cross sections are perpendicular to the x-axis.
Right.
This is top, and the bottom is x squared, right?
Okay.
What's the length of the base of our semicircle?
Top minus 1.
Okay, what is it? 9 minus
X 0.
x squared.
Right.
Okay. What is the area of that semicircle?
So equals pi over, or pi times the base, x over 2 of 9 minus x.
The base is 9 minus x squared, right?
Why are you-
Half of that is the radius.
And that entire thing is squared, right?
Why are you making this one perpendicular to x plus 9 instead of y?
What?
Why is this one perpendicular to x equals, or y equals 9 instead of the y
It's
axis?
perpendicular to the x-axis.
Where did you read that?
It's
Oh, you changed it.
yeah. Oh, your paper's different, isn't it?
Yeah, that's why I was
forgot
so
about that.
confused.
Okay. Yeah, so I changed your paper, this one x-axis. Okay. Do you understand where we generated this? Okay, so what is my integral now? From 0 to what?
9.
No,
X squared.
3.
Oh.
The x values are 0 to 3.
Would be negative 3 here.
I kind of set you up for that one. Oh, sorry.
Why do you,
Yeah, you're right.
it's negative 3? Yeah, 'cause that's the x.
I'm eliminating part of our shape. Negative 3 to 3. Because we're going all the way across, right? And then our formula.
Can you not simplify that at all?
You can. You can FOIL this out if you want to. This is going to be a calculator problem.
Oh,
You've done the calculus, you're going to get a calculator answer because it takes forever. Not forever, but it takes a while. Okay, so who had a hand up?
why is it 3?
Because we're integrating with respect to x. This starts at negative 3 and ends at 3.
Oh.
Yeah, how come the left one?
Because we're integrating with respect to y, which is 0 to 9. Yeah.
So the 9 minus x squared is your b value, and you got that by doing top minus bottom?
Yep. And this is the radius, right? Right here's the radius of the semicircle. So it's just pi r squared over 2. You just had to figure out the radius. Okay. And we could do that on a calculator. Questions? Okay. I'll spare you of the rest of it because we don't have time, but I have a for you. Your book doesn't really do this justice, so that's why we avoid it. I'm pretty sure I ripped them off from somebody. Teachers are thieves to the end. Honestly,
If I wrote
teachers are thieves. Not because it's bad, it's just, I don't have time to do all that.
Miss Schroeder, she would see all of her PowerPoints and she would go, I stole it fair and square.
Yeah,
Every
it's
single
basically,
Well, no, it would never have a name on it, it would have a different teacher's name on it.
okay, so,
Never did.
tomorrow,
That's fine.
you have a sub,
Right.
which sucks, but it's the way it is.
Why are you gone?